That's why we can actually do all the chat GPT stuff that uses literally billions and billions of variables to train and use the models. What did they do when they were first chips were successful? They spent money on improving those, improving the technology. So from billion variables, they went into maybe, I don't know the numbers, 10 billion, 100 billion. Now it's about the most recent one, the Blackwell chips, they can handle up to trillion variables. Good. But that meant NVIDIA had an option to expand. Maybe at the time, using the billion variable first chip, maybe the project was even losing money because there is a lot of cost to developing that. Once you make that decision, you have to spend a lot of money on R&D, right? And you have to train the people in Taiwan. The Taiwan Semiconductor Company is actually producing those chips to the specifications of NVIDIA. It's very costly, and these are not sunk costs. You don't spend the R&D money on that before you actually come up with the chips. And that option to expand is very valuable. You have option on timing. Let me give you a rather current example. As you know, due to some of you may call it courageous action, some of you may call it shenanigans of Trump's tariff actions. I don't care what your political beliefs are. In science, we argue with facts. The fact is, volatility has increased, right? So two things happened. Uh, since volatility has increased, people are less willing to make investments, long-term investments. Suppose I'm NVIDIA, I haven't done any of this before, and I'm going to decide whether or not I'm going to create a successful GPU business for, gaming computers, the graphic chips and that sort of stuff. The architecture is somewhat similar, but I mean, right now, whatever they have is the original GPU architecture on a lot of steroids. But the overall idea is the same, massively parallel computing. It's as if when you have those NVIDIA GPUs, it's as if you're doing calculations on 1 million different computers all at the same time. You have a mother that's every time I need to make 1 million calculations, mother says, okay, mother has 1 million children, says, you're going to do this one calculation, report it back to me. Maybe divides 2 by 3, okay? And gets all of that, puts them together and reports to the user. That's what massively parallel computing is. That's why computing is million times, not exactly a million, but maybe 950,000 times faster. Of course, it's expensive. I'm NVIDIA now, I'm this environment. Do you really think that I'm going to commit to spending all that money? And I don't know what the hell is going to happen. I don't know what sort of tariffs I'm going to pay on stuff I'm going to import from Taiwan, because that's where my people are. If I try to produce all of that here, A, I have to produce the capacity here that costs money, and B, more than likely those guys are going to do cheaper for me. Same thing happens. Suppose this is 2001 or 2003. I'm Steve Jobs, and I am considering coming up with iPhones. I know that in my supply chain, a lot of things are going to come from China. I am in this environment. Do you think I'm going to commit to making iPhones in this environment? No. That doesn't mean that project is not profitable. Right now, it may not be profitable, but if I put things in place, and as I suspect politically within about 6 months to a year, there's going to be so much pressure from Republican House members, from competitive districts, he's going to reverse all of these. He has the habit of declaring victory, whether he won or not anyway. Uh, so I'm NVIDIA. I'm going to say, okay, I'm predicting that this is going to be reversed. So I'm going to put my R&D architecture in place. Even though as of the prices now, given the tariffs on China and other countries, this is going to be a negative NPV project. But 1 year from now, when things change, all of that is going to change. I have the control over the timing of a lot of expenses. If this thing lasts 5 years, okay, I spend a lot of money on R&D, but I don't have to spend any money on tariffs because I'm going to abandon the project. So timing has that value. I'll give you another example. As a result of all of these, crude oil prices came down quite a bit. Let's just the graph. Look at the graph. Let's look at only 3 months. About 3 months ago, a barrel of this is probably West Texas Intermediate. More than likely, yeah. Which is not as sweet as Brent. In crude oil, sweet means it has more gasoline content and stuff. In fact, the sweetest oil is Saudi, I think. Uh, a lot of the new oil fields in U.S. are in shale oil. You guys have heard of shale oil or fracking? You basically get the oil that's in big rocks. Developing shale fields is very costly, and this has been done over the last 20 years or so, independent of any environmental effects. That was one of the reasons we had a big boom in North Dakota. And during COVID years, unemployment shot up in North Dakota a lot more than it shot up everything else because all those shale oil fields suddenly went silent. Now I'm an investor, possibly considering to develop a new shale oil field, and as cheaper fields have been already been used, it will probably cost me somewhere between $50 and $60 a barrel to develop it and extract that oil. At $60, that's not going to be very profitable. And let's say, for the sake of argument, it's going to cost me 65 per barrel. Does that mean that oil field is worthless? No. Why? Once I develop the field, I don't have to take out the oil. Okay? I can wait for the oil prices to go above 65. That's another timing option. And that's why you see people selling a lot of some of these established shale companies actually sold their assets. And some people paid a lot of money when the oil prices were about $10 a barrel. I mean, even in the best shale field, cost to extract it is about 40. You're paying positive amounts when you're losing $30 a barrel. But you don't have to sell that thing. Of course, in about 2 years, oil prices were about $100 a barrel. You have the timing option. So timing has value. I'm going to talk about one more thing. I realized this is not Monday, Wednesday. I was kind of going with 12:30 in mind. Uh, strategic options. This is option to get into a related business. I am sure when the NVIDIA people were evaluating this AI chips, they knew that if we can make this thing small enough, we could actually put them in PCs without generating too much heat. Within 2 years or so, you may have just regular PCs that have some of these smaller NVIDIA GPUs that does a lot of AI kind of computations. Okay, so that's a related business. Even though they're in the business of developing chips for networks or servers in general, they could also be in the business of PCs. In fact, they're going to build their own PCs and sell it that way, or uh, wait for Microsoft to actually write operating system for those kind of things and do it that way. But either way, those things have value. You can read about capital rationing. You know, I already posted the quiz. Make sure under yeah, chapter 9 content, I have these problem videos. You know, I go through a lot of different kind of problems. Make sure to watch them. And we're going to play Jeopardy on this part of chapter 9 only on Thursday. All right? See you guys Thursday. And I'll post this lecture sometime this afternoon.